Okay, so this is a brief video on how to calculate torque with with a force applied at an angle. So the first thing, I have two images here. One, I'm going to show you the best way to calculate torque, and then on the second image below, I'm going to show you what is commonly shown on the internet or on YouTube videos, or if you just Google calculating torque. And there's nothing wrong with the second way, but it's far more complicated than it has to be. So I'm going to show you the good way, and then I'll show you on the bottom the most commonly referenced way. So let me zoom in here. So here we have a force applied at an angle. And remember that torque is equal to F times R. Now, to be technical, we really should put a little perpendicular sign there, because it's really only the perpendicular component of the force that can produce a torque. So if we look at this applied force now, there is, I'll just call this F. There is F sub Y, and there is, if you were doing your components and stuff, F sub X. It is really only this F sub Y that is perpendicular to the lever arm, and so that is the only part that we're really interested in. So if you're going to calculate torque, what you want, and I'll go to be super obvious, we want this component here of the force. And so F sub Y is really just F sine theta. So if you want to calculate the torque on this lever arm, or whatever, just rotating thing, it's really going to be F sine theta R. And then, this would just be R right there. Okay, that's the best way to do it. You want to figure out what is the perpendicular component to the force, calculate that component, and then just multiply it by the lever arm. All right. Here's if you're stuck someday, or if you're trying to research this online, and you're trying to solve it, what you might see is something like this. Let me get to it here. So they come from the same place. Torque is equal to the force times the radial distance from the lever arm, the radius from the lever arm, the axis of rotation, sorry. So what they sometimes will say is that you need the perpendicular component of the lever arm. So there's a huge difference there. That what I'm showing in blue is that you want the perpendicular component of the force, and then you multiply it by the distance it's from the axis of rotation on the lever arm. What sometimes, like on hyperphysics.com, on Wikipedia, different YouTube videos, what I've seen is this a lot of times, is that you're looking for the perpendicular component of the lever arm to the applied force. It doesn't seem like a big difference, but it actually is, just in terms of conceptual. What they're saying is, don't adjust the force at all. Just continue this force. This is called line of action, by the way. Line of action. It's just, you just continue the force in a straight line like this, and you try to figure out what is the length of the lever arm, the adjusted lever arm, that is now perpendicular to this line of action force. So notice the difference here, that in this way right here, you're just getting the perpendicular component to the force. Here, you're adjusting the lever arm to make it perpendicular to the line of action of the applied force. I don't like doing it this way, because remember that this object right here, this object right here is a real object. It is a physical object that is going to be rotating. And so conceptually, it never made sense to me to adjust the orientation and the length of a real object to fit a force, which in a sense, a force is not an object. It's a force. So it never made sense to me that you would adjust the orientation and the length of this lever arm to make it fit the force, which is more of an abstract notion. Isn't it much easier to adjust this sort of abstract idea of the force and don't mess with the real object? Anyways, real quickly though, I do want to show you that what you get when you calculate it this way. Okay, so a little bit of geometry here. If this is theta right here, it turns out that this angle right here is also theta. And so if you want this length right here, remember that this whole side of the triangle would be the full R, or the length of the lever arm, if you will. So this component right here is really just R sine theta. So on their formula, the torque is going to be equal to F R sine theta. And notice up here, these two things are equivalent, right? So the physics all make sense. You're not going to get weird answers. But again, it's never made sense for me to do it the red way. It never made sense to me to do it the red way when the blue way above just seems more natural. Anyways, that's just a quick video to show you the difference between the two ways to calculate torque, and I would highly recommend the blue way.